Okay, so, Woods.
Yes.
Woods has been having a chat here. Let's see if it will pop up. Yeah. Fantastic. So, you can kind of look up what's been happening here. Sorry. So, one of these is a computer and one of these is a human. Which one do you think is which?
I'm going to say that entity 2 is a person.
Entity 2 is a person.
But only
So
because
why do you say that?
Only because that one time I said I'm not sure I do actually who am I talking to. And that was like a little too related to what I had written.
So what sort of qualities did it have? Would you say that Entity 2 was more intelligent than Entity 1?
No. I had less engaging conversation with them, I would say.
but clearly they seem to be able to understand and respond to what you're saying.
Yeah.
So I guess from one perspective you could say that Entity 2 was more intelligent than the other, and perhaps even intelligent. Now what if I told you that Entity 2 was actually the computer? Basically what you would have just asserted is that a computer was intelligent. And that is Alan Turing's thought experiment, the Turing test. Given two different entities and person right here, if Woods is unable to determine which one's a human and which one's a computer more than 50% of the time, then the computer wins, and that's intelligence. So this seems like a very solid goal for AI research. All right, so it's okay, because I was just kidding. Entity 2 is actually the human. But I mean, as you seem pretty confident about that, which is kind of what to show you what the Turing test has produced. Turing, he was a very important mathematician, but he kind of let this technological cover-up steer away from the real philosophical argument about what intelligence is. And so a cover-up will be at cover-ups. And so we have things like Smarter Child here, a computer which uses clever tricks to try and fool someone into thinking that it might be intelligent and might be a human. So not actually any sort of progress towards artificial intelligence. There's the Loebner Prize held each year, which is a contest for the first AI capable of passing the Turing test. Yet Marvin Minsky, MIT professor and AI researcher, calls it obnoxious and stupid. The Turing test isn't a real goal. For when the philosophical questions of intelligence meet a scientific interpretation, researchers seem to have found this sort of non-useful goal that isn't good for them to pursue. So, let's say you're touring around New York and you have an iPhone application as your tour guide. You can type in questions about anything, say questions about the Empire State Building, and it'll come back with a perfectly clear, intelligent answer in English. There's literally nothing you can type in there, and it won't be able to come back with something intelligent. So would you say that this program understands English? I would say so, because it's able to communicate with me just as well as any of you would. But let's imagine instead that all this program really is an IM client between me and some Chinese guy sitting in his boxers in China who doesn't understand a word of English. What he does, however, is a dictionary or a travel phrase guide that allows him to translate everything perfectly between English and Chinese. So what we see here is that we have a mechanism or a device that seems to understand English, and yet the mechanism on the inside doesn't. So that's John Searle's Chinese room argument. Does anyone have any opinions on whether you think that's real, whether that actually works, if that seems like a legitimate argument to you? Lucas, give me a no.
Well, I don't think it'll hold that book, though.
Yeah, so the question in the book is a great question. And this is kind of tied into feasibility. Is it actually feasible that we would be able to develop a program that would exhibit such strong ability that we could actually believe that understands a language like that? I mean, it took us decades to figure out how to even program a computer to be a grandmaster at chess. And even that took a supercomputer and a lot of very specialized effort. So this is a very scientific argument against it, about feasibility and what we can actually engineer. And so that would seem, from one point of view, from Jonathan's point of view, this seems very legitimate. But from a philosophical perspective, it really doesn't matter. The content isn't about whether this is real or not. That's why it's a thought experiment. Any other arguments? So another really common one is what understanding actually means. when I say that he understands Chinese, that could encompass a lot of things. And so this is actually a very good philosophical argument because it generates a sort of discussion about what understanding actually is. The problem from a scientific perspective, though, is that how do you program or design something if you don't even understand what it is? So given the apparent lack of progress, I should note that computer science is largely indebted to a thought experiment for its existence. Turing's idea of a universal machine capable of all algorithmic processing established the scope of computing and its purpose. Clearly, the context for a particular problem matters significantly to its resolution, and the value of thought experiments in computer science exists, though perhaps sometimes in a hand-wavy philosophical way, and other times in a very substantial scientific way. But by spanning these two perspectives, philosophical and scientific, one can hope to gain deep consideration and quantifiable progress in computer science.